I'm Ellie, and in this video we're going to look at how we can use bar models to help solve ratio problems. So let's have a look at the problem. Harry and David took turns driving to the theme park. Harry drove 3 out of every 5 miles that they travelled, and by the time they reached the theme park, David had driven 10 miles fewer. The question's asking us to work out how many miles Harry drove. So we're going to use the bar model to represent this information, because if the pupils read it really quickly without thinking about it carefully, it's quite easy to get the ratio wrong in this one. So let's read it again, this part carefully. It says Harry drove 3 out of every 5 miles that they travelled. So to represent the ratio, I want to show a bar with 3 equal parts for Harry. Now remember, ratio tells us how many equal parts, the relationship between those. So my parts that I'm now going to draw for David need to be the same size, they need to be equal. And it's if Harry's driving 3 out of every 5, that means that David is just driving 2 of those, because we've got a total of 5 equal parts. So for every 3 miles that Harry drives, this shows us that David drives 2. Now the question says, by the time they'd got there, that David had driven 10 miles fewer. Now we can keep our bar model like this because the ratio stays the same. But what we want to look at is this part of information here, 10 miles fewer. That represents this part. David has driven 10 miles fewer than Harry. So there you can see that actually this question is pretty simple to solve, because this is the equal part size to this. So if this represents 10 miles, then our equal part up here represents 10 miles, and all of these parts do as well. So when it asks us how many miles did Harry drive, it's a simple case of multiplying 10 miles by 3, and that will give us a total of 30 miles. And we can pop that back into the question and just say that Harry drove 30 miles. And that's how we can use bar models to help solve ratio problems.